Hi everyone. In this video, we got to understand some of the concepts behind simple pendulum. So we are going to solve some examples or problems that are related to simple pendulum. So without wasting much of the time, uh, let's get started. So we have a question which we are going to label as question 1. The figure below shows a simple pendulum that oscillates between position A and C. So that's a simple pendulum that we have. Then a part says if it takes 2 seconds for the bulb to move from point A to point C and back to B, find the number of oscillations. So here we've seen that it didn't go back to A, it ended at B. Since we know that the bulb have to move from point A through B, C, back to A again to make one oscillation. So how many points does it move? It moves 4 times. So if it moves from this direction to there, it's gonna be 1 out of 4. Then from there, it's gonna be 1 over it's gonna be 2 over 4. Then as it comes back now from point C to B, then we are going to have 3 over 4 because the bulb have to move 4 times to give us one complete circle. So if it now move from B to C back to A, so we are going to have then 4 over 4. If you divide this, it's going to give you number of oscillation as 1. Now, since the statement on A or the question on A is saying it only moved from A to C and back to B, so the number of oscillations that we are going to have to be number of oscillations is equal to 3 over 4. So you don't need to leave this under fraction, so you need to convert it into decimal points. So that's going to give us 0.75. Number of circles doesn't have the SI unit. You can just say that is equal to maybe circles, or you can also say swings, just like that. Then you end like that. So this is how we're supposed to handle what? To handle part A of the question. Then part B says calculate the period of the pendulum. So I want to calculate the period of a pendulum. So let me just adjust this next to this. So how do we handle this now? So let's correct the data then. Let's correct the data. So for this question, the data is here below. So we say we are looking for what? For period, we don't know. So number of oscillation we found because our bulb moved from A through B back to B. So we're gonna have number of oscillation as 0.75. Okay, then the time we are given in the question, which was saying if it took 2 seconds, so time taken was 2 seconds. So the formula is that period is equal to time taken over number of oscillation. So period of a pendulum is equal to 2 over 0.75. What does that give you? You can punch on your calculator. It's supposed to give you 2.67 seconds. Don't forget to put the SI in it. They are very much important in physics. Okay, so we've handled that question. Let's go to C then. So C says calculate the frequency of the pendulum. So we are going to use the equation that talks about the relationship between period and the frequency of the pendulum. So we do well know that the formula is frequency is equal to 1 over period. Why 1? Because we assume that for us to have one frequency, we should have at least one complete cycle. That's why it is like that. So let's correct the then data for this part of a question. So period of a pendulum we've calculated just above there, so it is 2.67 seconds. Then what are we looking for? We are looking for frequency. So frequency is equal to 1 over 2.67 seconds. What do we have? If you punch that one into your calculator, it is giving me frequency is equal to 0.37 hertz. Okay, so you do see that the questions were building up from what we did from the test. So even in the exam, don't forget what you've calculated in part A, because some data or variables that will give you in part A might be used to calculate the second question. Let's undo another question. So we have that one. So we can label this maybe to be part 2, or we can leave it like that. In an experiment to measure the period of a pendulum, the time taken for 50 complete oscillation was found to be 1 minute. What is the period of the pendulum? All right. So what was I always advise my students to correct the data first, because this will help you. So let's correct the data for this question. So I believe the question has given us number of complete oscillations. So oscillations is equal to 50. Okay. Then what are we looking for? Period. We don't know. Then what is the time given? So the time is given is 1 minute. So 1 minute. So immediately when you see minutes, these are other units. So the SI unit for time is actually seconds. So let's convert that 1 minute into seconds. So we know that 60 seconds will give us what? 1 minute. Okay, so 1 minute, it actually gives us 60 seconds. So the time here is going to be 60 seconds. So this is the one we'll use in our question. Okay, so we move on then to find this this question. So period is equal to time over number of oscillations. So that's gonna be 60 seconds over 50. Okay, that's gonna be, that's 0 goes, then 5 into 6, 1. Remember 1, we put a point, it can't go there. Then 5 into 10, it's gonna be 2. So this is going to be our answer. Period is equal to 1.2 seconds. Then we go to the next one. What is the period of a pendulum that makes 50 oscillations in 9 seconds? So that again, don't forget, number of oscillation 50, then time taken 90 seconds. What are we looking for? Period. We don't know. So period is equal to that over that, then 9 seconds over 50. and punch on your calculator. What does this give us? Okay, definitely this gives me 0.18 seconds. That's the correct answer. Okay, so we have another one. The pendulum has a period 0.6 second. Calculate the time it takes to make 75 oscillations. So our tradition is always to correct the data. So a period is been given, which is 0.6 seconds. Then number of oscillation or swings is actually 75. Then what are we looking for? Time taken, the interval. So if you want, you can play with mathematical gymnastics. If you want, for example, so period is equal to that over that. So you are looking for t, so you do cross multiplication. So time times 1 gonna give us t, then that times that gonna give us tn. So this is a formula to use, but however, if you are just okay with the mathematics, you can just go direct. For example, I just go direct. So period is equal to t over n. So I've been given period to be 0.6 is equal to, I'm looking for time, then 75 oscillation over 1, cross multiplication. T times 1 gonna give me t, then that times that, definitely gonna give me 45 seconds. Okay, so let's build up on that. We move on. Then suppose we have now this question: how many oscillations are made by a pendulum whose period is 1.2 seconds in 30 seconds? So we've been given what? Period, which is 1.2 seconds. Then time or an interval, it was 30 seconds. Then what am I looking for? Number of oscillation. So again, you can play with your mathematical gymnastics, but it still be the same. So t is equal to that over that. So I'm looking for n. So that's gonna be like that. So 1.2 is equal to time 30 over n. Cross multiplication, n times 1.1, 1.2 is going to be 1.2n over is equal to 30. So I want to remain with 1, I want to remain with n, so I'll divide both sides by 1.2. This is going to give me, how much is this? Okay, so this gave me actually 25 cycles or swings. So we're going to have 25 swings. Okay, then we have that, and say now a different scenario. This time around we'll look for frequency. So let's correct the data. So swings, number of swings was 96. Time taken was okay, that was a period. So period was 4.8 seconds. So how do we now handle this? Okay, this is actually time. I was right, it's time. So frequency is equal to number of oscillation over time. This time around we will not use this. Why? Because we've been given number of oscillation here. That's why we've opted to use this formula right here. So frequency is equal to 96 over time, that is 4.8. So if we compute that, it is going to give us 20 hairs. 20 hairs. Okay, then let's look at the different scenario again. This case, we've been given frequency. So frequency 15 hairs. Then what else given in the question? Time. So time taken was 3.6 seconds. Then what are we looking for? Number of oscillation. Oops, let me correct that one. Okay, so frequency is equal to number of oscillation over time. So since we've been given frequency to be 15, is equal to that which we are looking for, time 3.6, cross multiplication. So number of swings gonna be 3.6 times 15. What do we get? Get your calculator and do that. So me, I've found 54 cycles or swings. Okay, let's do the last one then. What is the time taken for a pendulum of frequency 25 Hz to make 40 oscillation? So data again. As a physics or science student, chemistry or physics, always get used to correct what you've been given in the question. So number of oscillation was 40. Then frequency was given to be 25 Hz. Okay. Then what are we looking for? We are looking for time interval. So frequency, number of oscillation over time. So 25 Hz is equal to that. Oops, let me correct that one. 40 over time. Cross multiplication. That will give me 25t. Then 1 times 40 going to give me 40. So I want to remain with time, so I'll divide by both sides by 25. Both side 25. So that goes. Then time, if we divide 25 into 40, definitely going to go 1. Okay, 1 time. Then we are going to have some remainders there, which believed to be, okay, so gonna give me, let me punch on my calculator. That gives me that. Okay, that's the period. So what do we learn from these calculations? So regardless of what you've been given, you can find frequency, number of oscillations, time interval, and the period. So just to clarify on one thing, if you've been asked to find frequency, in the question you've been given oscillation, always go with this formula. This formula. If the question has not given you number of swings or oscillations, but they have given you period, or you've calculated period, you have, okay, and they have asked you to look for frequency, always assume that you should have at least one complete swing. So the formula used is going to be 1 over period. So this formula is used when they haven't given you the number of oscillations. Okay, so don't forget the relationship between frequency and period of a pendulum. So you can either calculate any of this. It's not always period and it's not always frequency. They can ask you any of what we have in the formula. Then let's just look at some of the things or factors that affect the period of pendulum. Period of the pendulum. Okay, so the first factor is that acceleration due to gravity. Okay, or just a gravitation force. Okay, then the second one is actually the length of the pendulum. This is also same as length of the string. Because it is the string that makes up the length of the pendulum. Length of the string. Okay. Now, how does gravity affect the rate of period of pendulum? So let's see. Imagine on Earth we have the gravitation force of 10 Newton per kg. So we will see that most of things that we throw up, they always come down within a few seconds. Okay, so we could see that we have higher gravitation force. So if we have a pendulum right here, and we suspend it and we start moving the bob. So because of force of gravity being higher, the bob will move faster from that side to go back there, because there is the help of force of gravity as we suspend the pendulum. So how now? So higher force of gravity or acceleration due to gravity reduces the period of a pendulum. This is because the bob moves fast to complete one swing. So it reduces the period to be taken for it to complete one swing. So in short, higher gravitation force, the lower or the smaller the period of a pendulum. So if we go on moon, we go and experiment on pendulum. If we have a pendulum suspended, we are now on the moon. And there, the gravitation force is believed to be 1.6 Newton per kg. So just imagine, see the gap from 10 to 1.6. So definitely there is a lower force of gravity there. So what does this mean now? If we have the pendulum being experimented on the moon and we release the bob would take long just to move from there to reach point B. It goes to C and come back to A again. Definitely you're going to spend the hours there just to have your bob come back to C to complete one swing. So this will make your period longer, because it is taking time for bob to complete one cycle. So in simple terms, the lower the force of gravity or acceleration due to gravity, the longer the period of the pendulum. So lower force of gravity affect the period of a pendulum in the sense that they take longer, or the periods become longer due to the bob taking time to complete one swing. So those are the two factors that affects the period of pendulum. So I've explained on the acceleration due to gravity, how it affects the period of a pendulum on two scenarios, on the moon and on Earth. Now, how does the length of the pendulum affect the string? I mean the period of a pendulum. So we know that the length of the pendulum, it's the distance from the supporter to actually the center of the mass, or the center of the bob. So this is what we call the length of the pendulum. So let's just imagine we have a short length. Maybe we can imagine we have this. This is our pendulum that we have, shorter. Okay. So what does this mean? If we were to release this bob, it will move quick like that, because there within few seconds. So shorter length of pendulum, length of pendulum reduces the period of pendulum. So the period reduces. This is because the bob moves faster when we have a short length of the pendulum. So therefore reducing the period of a pendulum. If we have a longer length of the pendulum, we are going to have longer period of a pendulum. Why? Because it will take time for this bob to move from point A to point C due to the longer dangling of the string. So in short, longer length of the pendulum increases the period of a pendulum. This is because it takes time for the bob to move from point A through B, C, and back to A, while short length of the pendulum reduces the period of the pendulum. This is because it moves faster due to the short string attached to the bob. So this is how these two factors affect the length of the pendulum. So explain this in your exams and you get them correct. Now, what factors that do not affect the pendulum? Factors that do not affect the period of pendulum. Or the first one is the material used, or mass of the bob. They don't affect the period of a pendulum. Then the second one is actually amplitude of the bob. Okay, what does it mean? Amplitude is actually the highest displacement of the bob from the resting position. So the resting position of the bob is believed to be point B. So if we have that, that's A, B, C. Okay, so and this is the ground. So the resting position is this. This is the resting position of the bob. So now the distance from here, the resting position, to there, this is what we are calling what? Amplitude. So we are saying this distance, no matter how high you displace your bob, it will not affect the period of a pendulum. Other factors, you can put temperature, does not affect the period of a pendulum. So this marks the end of this tutorial video. You can watch it on my YouTube channel or my Facebook page. Thank you.